I just thought I'd make a quick introduction to the video. So basically this semester I've been working with 3 other students to build a solar panel that can track the sun. And my job, for the most part, was all the code heavy stuff. So I requested to my group that I'd be able to use AI somehow in this project. So I added phase tracking and solar tracking through AI and computer vision, but also it has a low power mode that just uses light sensors on the side, so it'll direct itself to the sun that way. So basically, we have 3 different modes: low power, phase tracking, and solar tracking. But other than that, the other things that I'm going to be showcasing off are I have a communication protocol to get information from everyone else's microcontrollers onto my board. My main board that I'm using is a Raspberry Pi, and they've basically all been using Pi Picos, so I needed a way to pull all their data and get it onto my website. So I am using UART communication with Interepts to decide which controller to talk to, and then using UART to get the communication across. I also built a website that displays basically all of our data. It'll graph all the power over time, and it will also just have like the current power of the whole day and different things like that showcased on it. Um, all this stuff is just in the first version right now, just getting it to work and doing all the functionality side of things. But basically, other than that, I also have a mode selector, which is just me pushing a button so it switches the mode, and it has a different light indicator so you can tell which mode it's on. Okay, so currently I have my Raspberry Pi running AI Vision, and right now it's just tracking my face. On the version that I have set up right now, it tracks my face, and if it can't find a face, then it'll start tracking the brightest object, which later the brightest object will be the sun that it's meant to be tracking. On the right side, you can see that it has the positioning information. So it finds the center of my face and says where it is. That's the top line. And then the next line is the left and right information. So all this information will be sent over eventually to servo motors that will be controlling the pan and tilt. So if I leave the frame, here's as if it was tracking the brightest object. So as you can see, eventually the motors will just turn until you get right in the middle, and then I'll say all the positions are good, and it will stay there. Okay, so if I clear the terminal real quick, I'll do a quick rundown. I'll go into this more later. But basically, here I have a Python program that's going to be serving my website to the internet. Um, so here's my Python program. I also have a CSS style sheet, and here's the actual code for the website. But again, I'll be going over that later. So if I run this program, it's running on my Raspberry Pi, and I open the website link. This is currently broadcasting on my current network. So as you can see, there's a couple fields for information here. This code did come from a previous project that I had. So all of this will change, all the names for the parameters and different things like that. As you can see, I only have one value updating here, just the amount for pings for the website. But as I have more information to update, talking to other people's in my groups, different values that they'll have, it'll be like power on panel 1, power on panel 2, power for the overall week. These values will also update, but right now, just to show that this is all functioning, I just have the ping counter going up. Here I have a graph. This is also just a bunch of random data being passed to the website right now. But basically this will be the power over the week. So you can see like the different days and the amount of power that it produced that day. And you can see the power chart. So you can see what time you were
peaking the most power, and obviously at night it'll dip down. But that's basically the quick rundown of my website. Later, I'm hoping to be able to also add a live stream of the face tracking. So you'll be able to see the computer vision running and what it's tracking. And I'll probably have on here a mode so you can tell which mode it's currently in. If it's low power, which then it's not going to be running any AI vision, it'll just be using light sensors. And then I'll have face tracking mode, so it'll be tracking your face. And then I will also have um, making it to detect the brightest object. And so basically it'll just be tracking the sun in the sky. But you'll be able to see, hopefully I'll have a window down here that it has a live stream from the Pi showing that all taking place and what it's tracking. Okay, here I'll be explaining my UART program, and that's just basically a communication protocol between microcontrollers and electronics. But just for background information, I got a picture pulled up here so you know what I'm talking about. Here is the Raspberry Pi. This is my main controller, and it's going to be our main computer basically for all of our programs to run on. It's been the controller that I've been using. But anyway, so here's the Raspberry Pi. Here is a Pico, Pi Pico board, and this is basically what the rest of my members have been using. All this stuff over here, this is for the mode selector, which I'll go over in a different part of the video. But basically, I'm using interrupts and UART communication. So an interrupt, basically, I have an interrupt running on this Pi Pico right here, and it's watching for the voltage of its pin to go down. And as soon as the voltage of the pin goes down, it raises a flag over here. And once that flag is there, it will be in this loop over here. And if it sees the flag, then it will send out the data, but I'll talk more about that in the program. But basically, I will set the value of the pin to low using this controller. Then this controller knows it's time to send data. I did that basically so later on I can hook up more than one controller up to this UART communication, and I can, depending on which controller I want information coming from, I'll just set the designated pin low for whichever microcontroller I'm trying to talk to, because we'll have multiple in our project recording different data values. But basically, once this pin goes low, this knows that it's time to send data. So then it will start sending data over this communication pin. So if I get rid of that now. So when I run this program here, it says starting, requesting data. I also have it set up so it can time out and it'll just keep trying to communicate. Right now I don't have this program over here running, so it's not getting any information passed to it. But once I hit run here, it'll be sending this data. So I have full values, I have decimal values, just to kind of get a full run through the test for all the different values that I might be sending over to this. But now as soon as I hit run, you see interrupt detected. It's the first interrupt it detected. This is the data that it's sending over. Here you can see it requested data, it was successful, and then here's the data that it was received. So as you can see, it's the same information. So basically when it says requesting data, it's just setting that pin to low. It's triggering this interrupt. So when that pin goes low, it says interrupt detected. And then I just have a counter so I know which one lines up over here. But so yeah, basically sets that pin low, sends data over here over UART, and then data is received, and here's the data. And then later on, I'll be using that data to update my website and different things like that. But here's just basically a showcase for this semester of what I did and my progress on it.
Okay, so here I'm going to be talking about my mode selector portion. Here, if I run the mode selector, it says main loop started. Press the button to change different modes. So here, If I push the button, it's currently changing modes. So basically, if it's in green, it'll be in low power mode. Red, it'll be in face tracking mode. And yellow, it'll be tracking the sun. And as you can see, every single time I push the button over here, it is changing the mode. And I'm going to use that variable later in my computer vision code so that it knows what it's tracking, and then it'll change what it's tracking, and it'll also turn off the computer vision if it's not needed at the time for low power mode.
Okay, here I'm just gonna do a quick rundown on my computer vision code. Here I'm just importing all the things that I need. Um, this is all basically set up in this first portion here. This is just making a file path to my Cascades folder. Basically, I was planning originally to run a full AI vision model like YOLO, but I found out that with only using a Raspberry Pi 4, it's not really possible. I mean, it was running, but it would crash and it was really slow. But when you're using Cascades, basically, instead of analyzing for a bunch of different types of objects, it is only optimized to find one thing. So the cascade that I'm looking for is my frontal face cascade. So basically, that's just giving it the file path for that. Um, Here, it's just loading that cascade error if it can't find it. Here, I'm setting up my camera. So the capture is video capture at 0. That's where I have my camera plugged into when I run it. It's just the location of it. And if it can't open it, then it shows an error. Here, I'm setting up my frame size, which is basically the frame of the computer vision screen that you see later when I'm running it. But it's just setting the height and the width, basic stuff there. But here's my main loop, which this is running every single time, or during. This is the loop that runs over and over and over here. So capture read. This is just getting a picture basically from my camera. This is true or not. Did it get it? And here is basically setting frame to the actual image. And if it wasn't able to get the image, then skip, try again. Here I'm converting my frame to a gray. It won't show up as gray. This is just to help the tracking. It's better if it's black and white. So just grayscales the image that comes from the camera. And here, all it's doing is basically taking the contrast and upgrading it or making it stronger. So there's more highs are higher, lows are lower. Just makes it easier for the actual computer vision to decide what it's seeing. It just adds more contrast to the image. Tracked, here I'm just setting the track variable to none. This is the variable that stores my position of whatever's being tracked. So the track changes between a face and the brightest object, but I'll go over that down here. So basically, if it finds a face in the image, it has an array of all the faces that it finds. So this is just if it found a face, if the array is bigger than 0, gives the position of it, draws a rectangle around it, and puts a label. This is just the font of it and what it says. So, and the color, I guess. So it'll draw a green square around a face, and then here's me just finding the track position. So this track variable then gets set to the center of that square that was made. And then say if it cannot find face, then track the brightest object, which later this will be changed so it depends on which mode you're in. So if it's in the face tracking mode, it will only look for faces. As if it's in the sun tracking mode, it'll only look for the sun. And later I'm going to change this to blob detection, but right now it's just picking the basically the brightest pixel in the image. Here is just the threshold for how bright the object needs to be for it to be tracked. Um, Eventually I'll tweak this so it's better at tracking the sun and it doesn't just track a bunch of random stuff. And I'll just play with that a little bit. But right now it's working with this value, so that's what I played with it a little bit before, but I got it to track with my lighter in here. So anyways, uh, this is basically the same as the face. This is just putting a circle around the brightest object. Here again, it's just adding a label, bright object to it. Um, and then tracked equals the location of the max value. Which that the reason why I don't have to do any math for this one is because it just picks basically the brightest pixel, finds it in um, the frame, and it gives you, so it's only one position because it's just the brightest pixel. Down here, so this is if something is being tracked, which this information will all change later as it'll be going to servo motors. But right now I just have it printing out to go up, left, right, or down, or if the position's good. So basically, if there's something tracked, print out the track position, which as you can see in my demo, uh, this is just basically the placement on the frame, which I basically knew, or my knowledge that I used for that was back when we were learning how to plot different data and different things on an LCD display. It basically works the same way. You just have um, X and Y, and it gives you an X and Y. So here, I'm splitting up the track position into the X position and the Y position of it. And if the X position is greater or less than, so if you take your screen, split it down the middle. If it's greater, then go right because it's over here. So then go to the right. If it's over here, go to the left. And right now here, it's just printing them out later. That'll go to the servos. And then if it's not out of bounds, left or right, then that position's good. So basically, if this is your screen here, or the frame, if it's over here, it'll tell the servo motors to go left until if this is an object that you're tracking, the motors will slowly bring it to the center, and then down here to left and right. So if it's over here, it'll say go down to the left, basically. It'll bring it to the center with the motors. But yeah, here is basically the same thing, just in the vertical. Y, the Y position, same exact stuff as here. Here it's just calling the show, basically the frame in that box. Later I'm gonna get this to actually send the image, hopefully to my website if I can get that working. Here's just a keyboard shortcut to quit. Here, cap release, that's just basically unbinding my camera and CV2 destroy all windows. When I start CV, it basically pulls up a whole, it pulls up a frame with the image that it's currently tracking, which all this stuff up here is basically plotting that square on the actual picture and everything. So you have your picture in color, what it's tracking, and then the label. But basically, in order to close out of that window, this code needs to be here. So waits for the break key, which you press key, and then it releases your camera and destroys that window, basically. Okay, here, so this is my communication protocol I got pulled up. On the left side here, I have my Pi Pico, and on the right side, I have my Raspberry Pi. Uh, One of the main reasons why I like VS Code is there's a lot of extensions, and so I have an SSH extension that allows me to connect to my Raspberry Pi through my Wi-Fi, and I can just remote into it, add files, use the terminal, all that good stuff. And then my Pi Pico I have just plugged in through the USB port, and I can create files, do this basically the same thing. One's connecting over Wi-Fi to the Raspberry Pi, the other one's connecting to the Pi Pico through the USB port. But if we pull up the Raspberry Pi Pico, so now this is just all the Pico files. This is a new Pico that I'm using, so this is the only thing that's on there. Okay, so here I have my Pi Pico program all pulled up. This is just connected to the Pi Pico. Um, but here is just all my imports on the Pi Pico. Here I'm setting up my UART communication. So it's just my communication speed, my baud rate. I just need to make sure that these are the same on my Raspberry Pi and my Pi Pico. That's just the communication speed that they talk at. Then the transmission pin and the receive pin. Here I'm creating my interrupt flag variable, setting it to not active. Here's my interrupt counter variable, set it to 0. It hasn't seen any interrupts yet. Um, then here I'm just setting the pin to a pull-up pin, um, just so I have a pin to use. And later this pin, right now it'll be sitting at 3.3 volts. And then my Raspberry Pi, when it wants to request information from the Pi Pico, it'll drop the voltage down because they're both connected. And they're on the same ground plane. So it'll go from 3.3 volts down to 0 volts and trigger the interrupt. So basically, I'll go over this and then come back to here. But this is setting up the actual interrupt. It's setting it to trigger on the falling edge. So the voltage is high, falls down from the Raspberry Pi, triggers this interrupt, and then it sends it to its event handler in serve. So here's the event handler. These have to be global as you can't pass anything to an interrupt. So these need to be global variables so they're within their scope. But basically, I'm just getting the interrupt flag and the interrupt count. So here, as soon as the voltage falls, I'm setting the flag to 1. So basically, that's just setting the interrupt to active, raising a flag here. I just did this so I know basically which count I'm on for my interrupt, and I'm printing interrupt detected. So I know that it actually detects each interrupt. But here I just have random data that I made, just an array of random data that I later send in here. But here's my main loop. It sleeps. If it doesn't see an interrupt flag, then it just keeps looping and looping and looping until finally there's an interrupt flag, goes true. So if there is an interrupt flag, set that back down to 0, um, and then show the interrupt count. And then for all the data in this array, I'm writing it over UART. I'm encoding it in UART, or encoding it in binary, and then I'm adding an end of the line. That this basically just means enter. It's the symbol for enter. So end of the end of the line. And then I need to encode that because I'm adding it. This is basically just taking the string of the data, and then for each of these, so this will be a 5.5 string, then I'll have a backslash n, 10.78 string, then backslash n, and that's all going to binary over the UART communication. Um, then I just have in between each send, I'm just pausing for a little bit. Um, here, after all this data goes through, so when it's done going through this whole list of data, then it sends done, and it sends that over to the Raspberry Pi, and then I just say print data sent and the data so I can verify it in my Raspberry Pi program, which I'll be talking about next. Okay, so here's my Raspberry Pi view. You can see I'm connected through SSH, but here I'm just getting all my imports, serial for the communication, the UART communication. Um, this is just for my sleep function, basically. Then my GPIO I'm importing. Here I was running into some errors that every single time I started my program, it was saying that the GPIO pins were already used in a different program. So just so I don't have that pop up every time, I set this to false so I don't see them. And just in case there actually is pins that were already set being used in a different program, I have it to clean those all up. So I'm running a fresh set of GPIO pins. Here, I'm just setting the GPIO pins to use the GPIO numbering and not the pin numbering. So, because the GPIO pin number and the normal pin number aren't exactly the same, and all my other code I use GPIO numbering. So, just to keep it consistent, I did that. Here I have my GPIO set up. It's pin 17, sending it out. Serial. this is me setting up my UART communication basically. So here, when you originally get a new fresh set of OS, you need to activate your UART communication. So basically, you need to go into the configurations and you need to turn off the password and enable UART communication. But once you do that, in the dev folder, there is a new file called ttyso. And basically, if you write to that file, then it will send information over UART. And if you read from it, that's if you have information coming into that or into your pin, it's basically writing to this file and you can read from it, um, which it'll make more sense down here. But here's just the baud rate, it's the communication speed. So basically, in UART communications, it's just sending binary ones and zeros over the signal wire between the Pi Pico and the Raspberry Pi. And so this is just making sure that their sampler rates are basically the same. Here's a timeout. So basically, if I didn't have, um, this is how long it waits. If it's listening for information to come through, if it doesn't happen within 1 second, then it will kick out and not keep trying to read this. Um, so here, I just have it say starting so it knows that it entered the main loop. Setting my receive data variable to blank. This is my array that I end up storing all my data that gets parsed later in the code. But just for blank slate in that array, then I'm saying requesting data. Here is when I actually set so right now the voltage on pin 17 is 3.3 volts. It's the same for the Pico, it sees 3.3 volts. But as soon as I set that low, it'll drop it to 0 volts. And then the Pi Pico sees this and it triggers the interrupt because it's a falling edge. And then once I do that, I enter my main loop. I start trying to read serial data. This I'm using read line because the way I set up my Pi Pico is when I'm sending communication or when I'm sending my values over the UART, I have a \n, which is the new line character. So this basically just strips all the lines or strips a line from the serial communication and saves it in the data. It says if there is data that's found, then decode it and strip off that new line character, save it in decoded data. Here's just some debug code that I was using. Um, and then it says if the data that it gets is done, then break, which it'll break it out of this loop. So basically, on my Pi Pico, I have my information getting sent from its array over there, and then once it reaches the end of the array, it'll send done. So if the decoded data is done, then I'll break out of the loop. Otherwise, it'll keep appending the the information to the received data array. So it'll get one line, strip off the character, decode it, and then stick it in the received data array. If it doesn't get data, so if it times out and kicks out for this timeout here, if it was listening for data and it didn't see any data coming over the pin for a second, then it'll kick out over here. And I just have it printing timed out, no date, no data was received, trying again. So it sets the pin back to high, waits a little bit to make sure that the Pi Pico sees it, and sets it to low, which will re-trigger the interrupt on the Pi Pico. Continue just means basically go back to the beginning of the loop here. So then I'll go back to trying to read information. But if it is successful and it does read all this data and it's done, then it will break out of this while loop and then go down here. Then all I'm doing is setting the pin back to high to reset the interrupt basically, saying data was received, and then for data and received data, so basically for all the values in here, because in order to make it so it wasn't a for loop, so just in case, um, because I don't know what size the data is going to be coming in, so it could be a string of like 5 variables or 10 variables. I use this, so for all the data values basically in this array, all I'm doing is printing the data, and then it sleeps for 1 second and starts the whole process of requesting data back all over again. Okay, so starting off here, this is my mode selector program. Here's all my imports. Here I'm just setting up all of my values to use down here later. I just put them all up here so then it's easier later for when I'm adjusting code. If I get a different strip, it's just all one section of code just for better organization. Um, but basically, it's just pixel pin is the GPIO 18. The number of pixels in the strip is 8. The the button pin, so the one that the actual button is hooked up to, is 25. The initial mode is 0 for low power. The last state I was just setting that to GPIO, high, setting it as high. The order of the pixels, I had to set that for RGB because later when I'm sending the information to the NeoPixels, if it wasn't RGB, um, there's different ones you can get depending on the NeoPixel. You got to change this. Mine is an RGB NeoPixel though. You can also get like RGB W, so there'd be another parameter here for the white value. So you can get wider and dimmer, and then there's also just they're like I think there's GRB. So this right now it's red, green, blue, but otherwise it'd be green, blue, red, different things like that. So just setting that so it's the actual color that I want. Once I actually send the values, 255 is the max, by the way. Um, so where was I at here again? Okay, so GPIO setup. This BCM basically, the original GPIO library that I'm using uses the actual pin number. So setting the GPIO.bcm, that makes it so the GPIO numbers are the ones that are being used instead. GPIO setup. Um, this is just setting of the pin. It's a pull down pin. All that information. Um, Technically, this isn't a hardware interrupt that I'm running because the current version of Raspberry Pi OS that I ran, it has some more safety features, and so it doesn't actually allow me to directly use hardware interrupts, which I was kind of sad about that. So basically, I had to make my own software interrupt, which I'll go talk about down here. So yeah, just setting up that pin. This is setting up the NeoPixel. This is the pin that it's on, the number of pixels, the brightness. I set this to 0.1 because to use less power for one thing. Also, it really doesn't need to be that bright. It's just an indicator for the mode. So you can tell which mode it's in right away just by looking at the color of the strip. Auto write, I have that set to true. Basically, all that's doing is if I had that for false every single time that I update the value, I'd have to have pixels.show down here, which then it would actually go and update the NeoPixel. But with this true, as soon as I set the values for the pins, then it basically prints that across all of them automatically. And then the pixel order is just set to RGB. So this is my software interrupt button. Down here, you can see that I needed the last state, the last known state, and the current mode. Basically, I'm passing that in there. And since it's not a hardware interrupt, I was able to just pass these in. And it doesn't need to be global variables, which is actually an added benefit. But so basically, I'm just passing them in, and then um, I'm just resetting them when it comes back out. But so once you enter this though, this gets called and it goes into here. Just checks the current state. If the current state is low, so if you're pushing the button and the last state was high, this makes it so it only triggers once. And it's not just every time it's low, it's triggering. It's only depends on the last value. So okay, and so then if that happens, then I have mode plus one modulus three. So basically that's just going to rotate between the remainders. So it goes 0, 1, 2, 0, 1, 2, 0, 1, 2 every single time you push the button. Printing out the mode, sleeping, debounce. Um, Then the last state turns into the current state, and then return the last state. That's so all of this works up here, basically. So um, it only detects it once. And then it returns the last state in the mode back out here, which then it gets passed back in. Then I just made a quick method. So my while loop, because later all this is going to be in one massive program with all my other programs. So I decided to split these up into easier to call methods. But basically I have an update LED, passes it the mode, which it gets from the button, and it's got a switch statement here. And if it's mode 0, set it to green. Mode or yeah, mode 1, set it to yellow. Mode 2, set it to red. And then, so yeah, this is basically the only thing in the main loop. It's just looping over and over, checking the button and updating the lights, checking the button, updating the lights. Later on, I'm going to be using this mode in my computer vision program too. But right now, this is just a pretty simple program. It's just checking the button, changing the mode, and then updating the LEDs. But yeah, later it will be used in the computer vision. This is basically why I even needed to have a mode selector button. And then here, this is just basically if I hit Control C, it exits the program, cleans up all my GPI opens. That just have if I don't clean them up, then when I try doing GPI opens, technically the hardware is all set up a certain way, so the GPIO is set up still. I would set up this whole setup is my pins are set up like that, and if I don't clean it up, then I run into warnings and different things like that, and I can have some weird stuff happening. So basically, it just takes all my GPIO, which is just this one pin, and clears it out. Um, so after that, I can switch over to my Pi Pico program.